Glass is 100% recyclable. It can be endlessly recycled without any loss of properties. Glass recycling has many benefits. It reduces the amount of accumulated waste and the extraction of raw materials. It reduces the energy consumption and CO2 emissions of melting glass. It can significantly increase the service life of the glass melting furnaces thanks to the decreased melting temperatures required for melting already formed glass and the less corrosive batch. But is glass really 100% recyclable? It depends on which stage of its life we focus on. Glass waste generating during production and processing, usually referred to as pre-consumer waste, is typically fully recycled back to the same product. Pre-consumer cullet generated directly at the float plant gets fully recycled, while glass that has been processed but has not yet entered the market needs to be first treated and then it can be recycled, as any contamination it has is calculable, rendering its recycling logistically easier. But that is not the case for glass waste occurring at the end of life of a product. There, the recycling percentage is considerably less. Here, only the glass container industry implements a successful closed-loop recycling, turning bottles back to the same product. For most other glass products, the closed-loop recycling of post-consumer glass waste is remarkably less. These include household utensils and appliances, such as tableware and ovenware, electronic waste, such as mobile phone screens and liquid crystal displays, light bulbs and tubes, solar panels, and automotive glass. Architectural glass products are no exception. Post-consumer glass waste is, in principle, downcycled to glass bottles, processed into low-value products, or landfilled. Multiple factors hinder the recycling of post-consumer glass waste, spanning from technical to supply chain barriers. Technical barriers include recipe incompatibility. For example, phone screens or Pyrex glass cannot be recycled together with float glass. These products have different glass compositions that cannot be easily mixed due to variations in thermal expansion coefficient, melting temperature, annealing temperature, and rate. Speaking of which, the only glass you should be placing in the recycling bin are glass bottles and food containers. All other glass products, and especially ceramics, cannot go in your local recycling program and will hinder glass recycling due to recipe incompatibility and contamination. Contamination is perhaps the biggest barrier in glass recycling. It can be virtually impossible to remove or so labor and energy intensive that cancels the benefits of recycling. Coatings, adhesives, lamination, ceramic prints all result in high levels of contamination that can be harmful for new glass products. Even small amounts of impurities, such as ceramics or metals, can act as stress concentrators and cause premature failure or lead to undesirable visible inclusions and discoloration in the glass. Even color contamination can be critical for some products, such as float glass, as it can alter the tint of the recycled glass product. A good example to explain this are the glass bottles. Darker color glasses, like green or brown, allow for more color contamination than clear glass bottles, which can accommodate very little cullet from green and brown bottles to maintain their characteristic hue. Focusing on supply chain barriers, these include the labor-intensive disassembly of multi-material glass products such as insulated glass units. The logistics involved in the transportation of glass cullet to treatment and recycling facilities, as well as the lack of such facilities for specialty glass, further hinder glass recycling. In specific, due to the high weight-to-volume ratio of glass, transportation, costs of external cullet to the treatment and recycling plants can amount to as much as 1/3 of the total cost of recycling and can be responsible for the highest amount of CO2 emissions produced in eventually substituting raw materials with cullet. Legislation further complicates the exporting and treatment of several glass waste streams, such as medical vials or electronic waste. Equally importantly, there is a lack of high-value products that are designed by the beginning to be from recycled glass.
With the above in mind, let's compare the current glass bottle recycling scheme with the recycling scheme of float glass to understand the differences. Compared to float glass, the glass container industry has a well-organized collection system. Glass bottles are in principle monomaterial and do not require an exhausting disassembly process. Moreover, they are subject to less strict quality regulations, allowing for the recycling of glass of different colors and more contaminants in the cullet compared to float. All these make the recycling process relatively effortless and cost efficient. Finally, let's have a look at the current situation of glass production and recycling within the European Union. Roughly 60% of the glass produced is for the container industry, which has a successful closed-loop recycling rate of circa 76%. This regards mainly post-consumer glass waste. Almost 30% of glass produced is by the float industry, which includes architectural and automotive glass. Only 10% of that glass is recycled back to the same product, and it is mainly pre-consumer waste, generated during production and processing. In fact, most float glass manufacturers do not recycle more than 1% of post-consumer glass waste. The last 10% of glass produced concerns specialty glasses like laboratory ware, crystals, glass for mobile phones, medical vials, light bulbs, etc. There is very little data available on the recycling of these types of glasses. With the exception of the bottle industry, most other glass products at the end of their life end up either downcycled to low-value products like insulation and aggregate, or even landfilled. In essence, glass waste remains a significant, unresolved problem, which raises the question, what can we do to increase glass recycling? Focusing on the technical barriers, research needs to be done to allow more contamination in new glass products. A solution can be also to invest on alternative glass recycling methods, such as the research that we do at TU Delft on recycling difficult-to-recycle glass waste streams via casting. Casting is a more flexible production method that allows us to easily switch between recipes and recycle many different compositions. Moreover, owing to the volumetric nature of cast glass, we are able to accommodate more contamination in the bulk where defects are rarely triggered. Focusing on the supply chain barriers, governments need to make more strict waste management legislations to trigger the interest of the industry to make further actions. Necessary is also to further establish local collection and treatment facilities for other glass types, not just for glass containers. Research currently done by several universities on establishing a QR code-like system for identifying the exact composition of glasses installed in buildings can further assist in recycling glass. Lastly, focusing on design, this can as well have a great impact in recycling. Designing for disassembly to prevent the laborious and energy-consuming dismantling of multi-material products, such as insulated glass units, can be detrimental. Key for the expansion of glass recycling is the design of end products with the provision of using glass waste as the initial material source. Glass recycling can unlock a whole new range of colorful, patterned, and exciting glass expressions that can only enrich our built environment and everyday life. So let's think of the potential.